Hello and welcome to Elimination Part 2, where we talk about multiplication and infinite solutions. So if you're trying to solve a problem and you realize that neither variable can be eliminated by simply adding or subtracting the equation, you can use the multiplication property of equality to eliminate one of those variables. And again, we're using elimination here, so the big thing we're trying to do is get rid of one of the variables. Also stressed in the earlier video, but I'm going to include it as well, we mostly want to use elimination when we have a problem and it is in standard form and A or B are not 1, right? Because if I have just like an x plus 2y, I'm going to solve for x there and kind of use substitution. That'll be an easy way. There's also going to be another video about that later on. So let's look at this. So if I were going to try to just simply add, and you don't have to write this in your notes, if I were to try to simply add these two together, I would get 8x plus 6y. Neither of those are eliminated, and the big part of elimination is try to get rid of one of our variables, so neither one of those are eliminated. If I were to subtract these two, then I would get negative 2x plus 2y, and again, neither are eliminated, so I know that I need to do something else. So what I'm going to try to do here is I'm going to try to get an opposite coefficient with one of my variables. And the way I want to do that is I want to look for coefficients that are a multiple of another. So I want coefficients that are multiples of the other. If I can do that, I only have to multiply one of my equations by something. So here, I'm going to look at my x's, and 3x, 5x, that doesn't really work. But if I look at my y's, 4y and 2y, well, 2y is a multiple of 4y. And in fact, I realize here, with my giant math brain, that I just have to multiply this whole equation by negative 2, and I'll get rid of my y's. And the reason I do that is because if I multiply this by negative 2, I'll get negative 4y, and negative 4y plus 4y, well, that eliminates my y's, which is what I'm trying to do the whole time. So I'm going to distribute that negative 2. So negative 10x minus 4y equals 8. And I add them up, and I get negative 7x equals 14, and divide by negative 7. Therefore, x equals negative 2. So, and I say so a lot, I'm aware, I have to plug it in. I need to find my y. So 3 times negative 2 plus 4y equals 6. Negative 6 plus 4y equals 6. Add the 6 over to both sides. 4y equals 12. And then y has to equal 3. So now we check that. And we always have to check that. We say plug it into the other equation. Again, we cannot plug it into that first equation. If we plug it into the first equation, that tells us nothing because we use this equation to try to find the y. So obviously it's going to work. We have to plug it into that other one. So 5 times negative 2 plus 2 times 3 gives us negative 10 plus 6, and that's equal to negative 4. And because it's equal to negative 4, we know that that works. So our final answer is negative 2, 3. Let's look at the next one. So here I'm going to try to look at my coefficients. So if I look at the x coefficient, I realize that negative 5 and 15, negative 5 is a multiple, or 15 is a multiple of, negative 15 is a negative 5 is a multiple of 15, or vice versa. And I can get rid of my x's there. So if I multiply this equation by 3, I will realize that I can have negative 15x plus 21y equals 51. And then I can add them, right? That's what we want to do. And we add them, and our x's are eliminated. And I'm left with 19y equals 19. Therefore, y has to equal 1. From here, I need to figure out what x is. So just like substitution, I plug it back in, and I have negative 5x plus 7 times 1 equals 17. I subtract 7 from both sides. That's a 7. So negative 5x equals 10. Dividing by negative 5 gives me that x equals negative 2. So I think my answer is negative 2 comma 1. Let's check if that's true. So I plug it back in to that other equation, the one I haven't used yet, and I say 15 times negative 2 minus 2 times 1, and that'll give me negative 30 minus 2, and that is equal to negative 32, and negative 32 is equal to negative 32, so we are correct. Our final answer is negative 2 comma 1. So here, pause the video. Just a warning, your answers will be fractional here, so make sure you are aware of that. And pause the video, try it out. When you're done, come back. Okay, so you think you have the answer, and if you have negative 3/2 comma 7/4, or negative 1.5 or negative 1.5 comma 1.75, you are correct. Move on. If not, stick around. I'll show you what I did. So here I'm going to try to get rid of my y's because I have negative 2 and 6, and I can just multiply this left equation by 3 to help to get rid of those y's. Okay? If I were to try to do it with the x's, I would have to multiply by a really weird number, and it wouldn't be as pretty. So negative 15x minus 6y equals 12. Oh, I just decapitated the 6. There we go. And then I add those up, and I get negative 12y equals 18, and I divide by negative 18, and I get x equals negative 3/2, because I'm not a scrub, and I realize that both of these are easily divisible by 6, and that will give me negative 3/2. So that's the x value. And now I want to see if that's the y value. So I'm going to do negative, let's use the left one, or let's use the right one. We always use the left one. Let's use the right one. 3 times negative 3 over 2 plus 6y equals 6. So I multiply the 3, and I get negative 9 over 2 plus 6y. And I'm going to rewrite that as 12 over 2 because I want to have that common denominator, right? I want to, when I'm going to be combining those, I want to have that common denominator. So I add 9 over 2 to both sides, and that'll give me 6y equals 21 over 2, which is great. And then I have to isolate the y, so that's the same thing as me multiplying. Dividing by 6 is the same thing as me multiplying by 1/6. So then what I realize here is that these are going to simplify, and this is going to reduce down. I can divide both of these by 3, which leaves that at 2, and that to 7. So that gives me 7 over 4, which is my y value. Now you could also plug it in and make sure it works, but here I'm telling you it does work. So if you were to plug it in, it's a lot of work, but you get there. So now let's check, what if we can't just multiply one of them, right? There's no number going from here, at least no whole number going there, that would let me try to get rid of one or the other. So here it's kind of a pick or choose thing. I just need to get opposite coefficients. Again, we're trying to get opposite coefficients, so that way we are able to get rid of one of our variables, to eliminate one of our variables. So I'm going to try to get rid of my x. That's what I want to do. I'm going to say, let's get rid of the x. So if I were to do that, I need to get opposite coefficients. Now, the opposite coefficient that I can get here is 12. That's really the number that I'm going to get up to. So I could multiply this one by 4 and this one by 3. Notice how I'm kind of just switching the coefficients here. I'm multiplying that one by 3 and that one by 4. However, this will not give me an opposite coefficient. So I have to multiply one of these by a negative. It doesn't matter if the negative goes here or if the negative goes here. But the negative has to go to one of them. I'm going to use the top one because I want to. So I distribute that negative 4, and I get negative 12x minus 8y equals negative 4. For the bottom one, I'm going to get 12x plus 9y equals negative 6. And then all I have to do is add up these equations, because now I have opposite coefficients for my x's. So what that has allowed me to do is now I can just focus on the y's, and I can solve for those y's. So that's going to give me y equals negative 10. So that's part of my answer. Now all I have to do is try to get my x. So I plug negative 10 into one of those equations. Again, doesn't matter which one, just pick one. So 3x plus 2 times negative 10 equals 1. So negative 20 equals 1. So 3x minus 20 equals 1. I add 20 to both sides, and 3x equals 21. Solving it from here leaves me with x equaling 7. So we think my answer is 7 comma negative 10. And to double check, I plug it in to the opposite equation. So I have 4 times 7 plus 3 times negative 10, which is 28 minus 30, and that will equal negative 2. So that's good. Our final answer is 7 over negative 10. Oh, sorry, 7 comma negative 10.